Math. This is a part 2 of a study guide for the first test or first exam in a Calculus 3 course being recorded in spring semester 2026. I had to do a part 2 because my pen that I'm writing with was having like a seizure, so I restarted my computer. And the first part, if you're looking for first part, just look at my channel under the Calculus playlist. It should be there. It should say part 1. And I did numbers 1 through 9. So I'll be starting this one on number 10. Right? The order really doesn't matter, though. They're kind of all mixed up, so you're welcome to watch this part first. It doesn't, again, really matter. So I'm starting on number 10. Hopefully my pen is behaving now. Who knows? I'm sorry. All right, so we're coming here to number 10. Yes, all the answers are already in because I already did this, so I'm just going to be covering them up and explaining. There is an embedded Desmos calculator, and that's all we have. All right, here's convert these points that are kind of normal Cartesian points into cylindrical coordinates. All right, so we're going from XYZ is 2, 1, 3 into this coordinate system, the cylindrical coordinate system. So we do have some formulas that you want to know. If you're allowed a formula sheet, jot these down. R squared is y squared plus z squared. Tangent of theta is y over x, and z remains z. Jot those down. So that is how to turn regular Cartesian points into cylindrical. In part 1, I messed with spherical. So again, go back and watch part 1. So now all we need to do is do that. So follow our formulas. We have r squared equals, there's x, there's y, there's z. So that would be, oops, I wrote that down wrong. R squared, scratch that one, r squared is x squared plus y squared. There we go. So now we have r squared is 2 squared plus 1 squared, so that's 4 plus 1, so r squared is 5. Take the root, r is root 5. And now next one. Tan of theta is y over x, so that would be 1/2. Take the inverse tan, so tan theta is inverse tan of 1/2. And could we actually figure that out? Yes, probably. So I guess we maybe should. So this angle right here is pi over 6, which is root 3 over 2, 1/2. Is that tan 1/2? Actually, no, I don't think we need to figure that out. Let's just leave it. Let's just leave it inverse tan 1/2. Yes, you could probably put that in the calculator. Let's have it set to radians for a second. So let's do inverse tan of 1/2. So I get that this is approximately 0.4636. But I would just leave it inverse tan 1/2, and the program took that. And then finally, z remains z. So z is just 3. So final answer I got is root 5 tan inverse of 1/2, which I'm sure you could just put in 0.46 if you want, and then 3. This is what the system took for me, so that's what I did. Let's see the little key there, see what they want for the 0.46. Yeah, that's fine. And they went ahead and did root 5 is like 2.2. You don't need to do that. Root 5. Yeah, it's fine. All right, number 11. Find k so that these two vectors will be orthogonal. Orthogonal is a fancy word for perpendicular. So you can see that note there. They form a 90-degree angle, hence perpendicular. All right. So we just need to know this rule. It's not really a formula, but a rule. If the dot product is 0, then A and B are orthogonal. So you just need to know that. So let's dot these two together. Let's do A dot with B. So that would be A dot B. 1 times -4 plus -4 times -3 plus -1 times k. And if we want them to be orthogonal, we're going to set that to 0. Set that dot product to 0. Solve. So that would be -4 plus 12 minus k equals 0. That would be 8 minus k equals 0. Let's add that over. 8 is k. And that's the question. Find k. 8. That's one of the easiest ones on there if you just know that rule that the dot product needs to be 0. Number 12. This one is pure trigonometry. I would not even call this is not calculus, honestly. So it says without using a calculator, even though that calculator button is there, we want the exact values of sine and cosine of 300. Okay, if your unit circle knowledge is strong, this is a very easy question. So we are in degrees. So you know this is 0 degree. 90, 180, 270, and all the way back around is 360. Well, we're at 300. So that's just a smidge past 270. So here we are. This angle is 300. What quadrant? 1, 2, 3, 4. We're in quadrant 4, so that's this right here. What quadrant is this angle? And then they're asking for a reference angle. That is going to be how far you are from the straight edge. So we're at 300, we need to get to 360. So how far would this be? This would be 60. So there's our reference angle. And so that means if you draw 60 degrees up into the first quadrant, that's the third one on the unit circle, right? It goes 30, 45, 60. That's our reference. And if you know your unit circle, this point, which is 60 degrees, which is pi over 3 in radians, is 1/2 root 3 over 2. So the reason we use a reference is because then we just reflect that reference. So let's reflect that down into quadrant 4. And we know in quadrant 4 that the x values are positive because we're going right, but our y values are negative because we're coming down. So you're going to keep the x value 1/2, keep that positive, and negate your y value. CS. So cos of 300 is 1/2. Sine of 300 is negative root 3 over 2. Very easy question if you know your basic trigonometry. Done. Okay, coming to 13. This is one of the harder ones. And it's not actually that hard, it's long. So buckle in on this one. We are given the acceleration of a particle in a vector formula there, and we need to get all the way back to the position. Okay, so the r of t is the position, the v of t, which is r prime, is the velocity, and the a of t, which is r double prime, is the acceleration. That is what we've been given. So we need to work our way backward. We're going to be integrating here. So let's integrate, and you're going to do that separately, each component of that a vector. Okay? Integrate 5t with respect to t. Integrate 6 sine t with respect to t. Integrate cos of 6t with respect to t. So do all that separately. This one's the easiest. You're just going to do 5t squared over 2 plus some constant, and let's call it constant 1 because there's 3 problems, right? The second one, pull this 6 out. And now the integral of sine, whose derivative is sine? Negative cosine. So this would be 6 times negative cosine of t, and then plus constant 2. This negative would look better here. So this is negative 6 cos of t plus constant 2. And the third one over. This is kind of like our u. We need his derivative, right? So we need a 6. Put a 1/6 to keep your balance. So now, what's the integral of cosine? This is done now. Whose derivative is cosine? Sine. So we say sine of 6t, and we drop the 6th constant 3. All right, we need these 3 constants to continue this problem. That is, so we've now integrated the a, we're at the v. These 3 make up the velocity, but we can't just leave these random constants. We need to know what they are. So we are given a clue. Right here, this middle line, velocity at 0 is this. So plug in 0 into all these. So it's going to be 5 0 squared over 2 plus c1, and that would equal this first number. negative 4. 0 squared is 0. This is just going to knock out. So C1 is negative 4. Keep going. Go to the second one. This will be negative 6 cos, plug in 0, because that's what this is evaluated at, plus C2 will be the middle number, so 1. Cos of 0, go to unit circle, here's 0, is 1. So this will be negative 6 times 1 plus C2 is 1. So negative 6 plus C2 is 1. Add 6, C2 is 7. Go to the third one, plug in 0. 1/6 sine of 6 times 0 would be 0, plus C3 will be the third answer, negative 5. Come back to the unit circle, sine of 0 is 0, so this one's gone. C3 is negative 5. Okay, I'm going to have to cover some stuff up here. We're done with that. So we just found that the velocity is 5t squared over 2 minus 4, negative 6 cos of t plus 7, and 1/6 sine of 6t minus 5. So if we were just finding velocity, we would be done. But we're not. We need to go one more time, do the same thing one more time, integrate. Okay, integrate each piece. So I'm going to integrate this first one. I'm going to write this as 5/2 t squared minus 4 with respect to t, minus 6 cos t plus 7 with respect to t, 1/6 sine of 6t minus 5 with respect to t. All right, I'm just going to go up over top of this for a second. I have it written down on my paper, so I can come back to that. Just need the room. All right, let's integrate. First one, we would do 5/2 t cubed over 3 minus 4. Now this technically has t0, so you would bump that up to t1 over 1, but nobody writes the ones. Plus C1. So that's going to be 5 over 6, right? Multiply. T cubed minus 4t plus C1. And again, we'll get the constant in a minute. Going to the middle one. Split this up. You are allowed to split integrals. That's fine. Let's move negative 6 to the side. That's fine. Integral of cosine. Whose derivative is cosine? Sine. So that would be sine of t. Drop the negative 6. And again, this has t0, so that would bump up to t1 over 1, which we don't write. So that would just be t plus constant 2. Last one over. Again, split this up. You're allowed to do that. Let's pull this to the side. We're allowed to do that. Now put dt there. Technically, this was dt. Okay. We need this again is kind of u. We need the derivative. So we're going to put a 6. Put a 1/6 to keep your balance. All right, integral of sine. Whose derivative is sine? Negative cos. So that's going to be negative cos 6t. 1/6 times 1/6 is 1/36. The negative would look better here. So negative 1/36 cos of 6t. And then this one has t0. So that's going to be minus 5 t1 over 1. But again, we don't write the ones. Plus constant 3. Okay, so your integration game does need to be, pretty good there. And now we're going to find all these constants. I went up over it, but they told us r of 0 is negative 3, negative 2, 3. So again, we're going to put in 0 into all these little pieces and find the c. So going into the orange one, that would be 5/6 times 0 cubed minus 4 times 0 plus c little 1 needs to be negative 3. This is 0, this is 0. C1 is negative 3. Okay, going to the green one, plug in 0. So this would be negative 6 sine of 0 plus 7 times 0 plus C2 needs to be negative 2. The sine of 0 is 0, so this is gone. 7 times 0 is 0. So C2 is -2. And coming to the pink. -136 cos 6 times 0, so 0, minus 5 times 0, plus C3 needs to be 3, the third number. Cos of 0 is 1 from that unit circle previously, so this is -136 times 1. 5 times 0 is gone, plus C3 equals 3. So this is -136 plus C3 equals, I'm going to call that 3 over 1, and I'm going to times that by 36 to get a common denominator. That's 108/36. Add 1. Of course, use a fraction calculator if that's allowed. And C3 is 109/36. So now the final question was give this the R function, the position function. So we integrated twice to get back to that. So your final result here is R of t. The orange answer, which was 5/6t cubed minus 4t minus 3. The green answer, -6 sine of t plus 7t minus 2. And then the pink answer, -136 cos of 6t minus 5t plus 109/36. That is your final answer. That one's pretty nasty. That was 13. I'm just checking that there. Did I get that? Yeah, I think so. Eliminate the parameter. Okay, much easier here. So here we don't want t. We want x as a function of y. So right now we have x as a function of t. So that means come to this one and eliminate t, or solve for t on the second one. So we have y equals -6 plus 5t. Solve for t. Move that over. So y plus 6 equals 5t. Divide 5. So we have y plus 6 over 5 equals t. All of it over 5, like a big fraction. Now, pick that up and go into the x function because we want x equals something. Put it in for t. So x equals -5 times what we just found for t. Y plus 6 all over 5 squared. So x equals -5. When you're squaring a fraction, you can square the top and you can square the bottom. Okay, so that's now -5 y plus 6 squared all over 25. But -5 over 25 you can reduce. Divide by 5 would just be -1 over 5. We're not going to put the 1. Y plus 6 squared. That is x in terms of y. Answer, I did not square that out, like FOIL it out. You probably could, but I don't think you need to. Answer. Much better than the previous. Number 15. You are just integrating, and just once. So if you could do that problem 2 problems ago, you can do this one easy peasy. They're just telling you to find the integral of r of t, and it said don't worry about the plus c's. So that's nice. Okay, so just do every piece separately. So we have 3 pieces. So we're going to integrate -3t cubed minus 1 with respect to t. Integrate -2e to the t with respect to t. Integrate 2 sine of 4t with respect to t. All right, first one, just bump it up. -3t to the 4th over 4. This has t0, so it'd be -1t to the 1st over 1. And then I would just write that as -3/4 t to the 4th minus t. We could just ghost the ones. Okay, there's your first one. Answer for the first part. Second part, let's pull the -2. We're totally allowed to do that. And then e to the t. We technically need this guy's derivative, which is 1, and we've got it. 1's a ghost. Now we're good. E to the t is his own integral. So this is just straight up -2 e to the t. Done. Second part. Last part, pull the constant. So this 2, pull it out. This is kind of our u. We need its derivative. The derivative of that would be 4. So put a 1/4 to keep your balance. 2 times a quarter would be 2 quarters. 2 quarters reduces to a half. Integral of sine is whose derivative is sine. That would be negative cos. Keep your argument. Put the negative in front. It looks better. Negative half cos of 4t. Answer. So then just type in those 3 answers. Done. That's the integration. 15. Here we're taking the limit of a vector function. So again, you just take the limit separately. So you're going to do 3 little baby units, limits here. So limit as t approaches 2 of the first thingy. We're just going to plug 2 in. That's just a polynomial function. We can just plug it in. So that would be 5 times 2 squared plus 2 times 2 minus 2. So 5 times 4, so 20 plus 4 minus 2. 24 minus 2 is 22. There's our first answer. Middle one. So limit as t approaches 2 of t squared plus 3t minus 10 over t minus 2. Now we have an issue here. If you put in 2 on the bottom, 2 minus 2 is 0, and we can't do a number divide 0, right? We can't divide by 0. It's not defined. So here, remembering back to your Calc 1, we're going to do L'Hopital's rule, where you take the derivative of the top and bottom and you try again. So now let's do limit as t approaches 2. Take the derivative of the top, which would be 2t plus 3. Take the derivative of the bottom, which would be 1. Nobody cares about a 1, right? Not on the bottom anyway. Plug in 2 now. So this would be 2 times 2, so 4 plus 3, 7. That works. So again, the first time we busted basically because the bottom was 0. L'Hopital's rule, we took derivative of top, derivative of bottom, and we tried again. And that worked. Third one, limit as t approaches 2 of 5 cos t. Just put 2 right there. 5 cos 2. Could you push it in the calculator? Yeah. Do you need to? No. They took that. Those are your 3 answers. Okay. 17. Find the curvature of a curve at a specific point. I think this is one of the hardest ones. It's got a lot of math to it. A lot. Okay. We need a formula here. Write this down if you're allowed a formula sheet. Curvature is denoted by K, and it is the magnitude of R1 at that point cross R2, or excuse me, let me try that again. It is the magnitude of R prime cross R double prime all over the magnitude of R prime cubed. All right, so we need to find R prime and R double prime. Okay, so finding R prime of t. So derivative of cos would be negative sine. Derivative of sine is cos. And derivative of 5t is 5. And now plug in the value. It says t is 0, so do R prime at 0. So that's negative sine of 0, cos of 0, and then there's nothing to plug in, so that's 5. Sine of 0 is 0. There is no negative 0. Cos of 0 is 1, and then 5. So that is our R prime. Now do the second derivative. So R double prime. So taking the derivative of the derivative of negative sine is negative cos. Derivative of cos is negative sine. And derivative of 5 is nothing. Now do double prime at 0. So that's negative cos of 0, negative sine of 0, and 0. Cos of 0 is 1, so that'd be negative 1. Sine of 0 is 0, and 0. There is double prime. So again, you're taking your derivative game has to be strong there. Unit circle needs to be strong as well. Okay, now cross those two. So do R prime cross R double prime, the like answers. This cross with this. So we have to do the IJK prime was 0, 1, 5. Double prime was negative 1, 0, 0. We have I always minus j plus k. And then you do the cross-cross thing. So after you eliminate I, what's left? 1, 5, 0, 0. After you eliminate j, what's left? 0, 5, negative 1, 0. After you eliminate k, what's left? 0, 1, negative 1, 0. Let me make sure that all matches what I have on my paper. Okay, good. And now let's work this out. So that's going to be I times, go crossways, that'd be 0 minus 0 minus j, 0 minus negative 5, that'll turn to plus, and k, 0 minus negative 1, that'll turn to plus. So we have 0i minus 5j plus 1k, and I like to write it this way, 0, negative 5, 1. There is our cross product. Let me make sure that matches what I have. Yes. Okay, I got to erase some stuff, so pause me if needed. Coming up here to the top, it says to do the magnitude of the cross. Oops, I need something that I erased. We need the blue. Let me write that down. R prime was 0, 1, 5. Okay, now I can go up on top. All right. So we need the magnitude of the cross. So the magnitude of the red answer. So that's going to be root, because magnitude is root of each individual component squared. So 0 squared plus negative 5 squared plus 1 squared. So that would be root 25 plus 1, so 26. And on the bottom, we're going to do the magnitude of the prime cubed. So magnitude of prime would be the blue one, 0 squared plus 1 squared plus 5 squared, and then you're going to do that 3 times. Well, that's 1 plus 25, so that's root 26 3 times. So that's root 26 over, and then I just wrote this 3 times. There's other ways to do this, but you can see that one of these cancels. And we're left with 1 over root 26 squared, which will bust out, and 1 over 26. That is the curvature. They asked for it as a decimal, so that came out as 0.038. They said round 2 places, so approximately 0.04. That's a pain, for sure. That was 17. Ugh, the next one's a pain too. And again, I can't even explain really what we're doing on this next one. I can do the math, but I don't know why. Okay, so we are finding a plane through those 3 given points. Okay. So I had to look this one up and kind of get directions here. So you're going to call your points P, Q, and R just as a labeling convention. So here's P, here's Q, here's R. So step 1 is to determine the normal vector by doing PQ cross with PR. So let's find the vector PQ. So you do second x minus first, so that's going to be negative 2 minus 8. Second y minus first. And second z minus first. So that's going to be negative 10, 0. That is PQ. And now I'll kind of do the same thing, but do PR. Let me get a different color. Okay, so that's going to be second x minus first, so negative 4 minus 8. Second y minus first, so 3 minus 2. Second z minus first, so 4 minus 2. So that's going to be negative 12, 1, 2. Okay. Now, you do that. So you find the vector PQ, find the vector PR, and then we are going to cross them. And the result of that will be the normal vector. So cross PQ with PR. Oh, is my pen giving out again? I, J, K. Negative 10, 0, negative 12, 1, 2. Okay, so again, it's I, something something minus j something something plus k something something. When you cross out the I row and column, you would be left with negative 10, 0, 1, 2. When you cross out the j row and column, you would left with negative 10, 0, negative 12, 2. And when you cross out the k row and column, you'd be left with negative 10, negative 10, negative 12, 1. So work that out. That would be I, always go crossways, so that's negative 20, always minus, go the other crossways, that's 0. Minus j, crossways is negative 20, always minus, that's 0. Plus k, crossways is negative 10, minus, that's regular 120. So we get I times negative 20 minus j times negative 20 plus k times negative 130. So our vector would be negative 20. Note that this is minus minus, so this would turn to 20 and negative 130. That is our normal vector. But look at that. I don't love those numbers. They do have a common factor of 10. So you are allowed to go ahead and cut those all by a 10. So divide out the common factor of 10. And we now have a normal vector of negative 2, 2, and negative 13. Okay, that is going to be the coefficients, and then pick any of the points, but they recommend, like the example I watched said pick P, so your first point. So pick that one. With these as your coefficients. So the plane, this will be your coefficient, so negative 2, and then you do x minus the x coordinate, so 8. Then this will be your next coefficient, so positive 2. Then you do y minus the y coordinate, so 2. This will be your next coefficient, so negative 13. And you do z minus the z coordinate, so 2. And then you set that equal to 0. Now you might be able to stop there. That might be good enough. Let me actually see if that works. Because if we can stop there, why not? I went ahead and distributed. Let me see if this works. What if you just did negative 2x? Did they yeah, did they take that? Yeah, I think so. Or you could go ahead and distribute it. So just for kicks and giggles, I'll do that. So that would be negative 2x, oh, my pen's going again, plus 16 plus 2y minus 4 minus 13z plus 26 equals 0. So that's negative 2x plus 2y minus 13z, and then put the constants together. 16 minus 4, that's 12. 12 plus 26 is 38. That's what the orange is, what I put in the first time I did this, and it was correct. But I don't know if you really need to distribute. They would probably take it either way, but the orange I know for sure is fine. Alright, it seems like my pen is just not working again. I'll try to keep going, but if it starts getting bad, I'll just restart and do a part 3. Restart my computer and do a part 3. Find the angle between the vectors in radians. So again, this is a formula. If you know the formula, it's not awful. So the formula is to find the angle in between these two vectors. Cos of theta is the two vectors dotted, so A dot B, over the two vectors magnitude, A magnitude, B magnitude. Usually we use U and V, but it doesn't matter. Okay, let's go ahead and dot those. So that would be negative 3 with negative 4. Yep, my pen's going. I will go ahead and finish this one, then I'll have to restart yet again. Plus 5 times 2 plus 3 times negative 1. And so that would be 12 plus 10 minus 3. So 22 minus 3, so 19. And on the bottom, we would have square root negative 3 squared plus 5 squared plus 3 squared. I'm so sorry for my pen. It is beyond annoying. Negative 4 squared plus, and all under a root here. 2 different roots, right? 2 squared, negative 1 squared. Oh my gosh, this is so annoying. All right, I wonder if I can just type up on top of it. So that would be square root of 9 plus 25 plus 25. So that one would be 59. And the other one would be 16 plus 4 plus 1. So 21. Yes. So I am now at cos theta equals, the top is 19 and the bottom is root 59 and root 21. You are allowed to multiply roots, so let's go ahead and do that. So that's going to be 19 over, multiply 59 times 21, and that is, oh, hold on here. That's a 3. This is not 59. This is 3, and my pen being bad made me misread that. So this is 25 plus 9 plus 9, so 34 plus 9, so 43. That first root is 43. The second root is 21. So this is root 43. Sorry about that. So we now multiply 43 times 21, and that is 903. So we have cos of theta is 19 over root 903. So theta would be the inverse cosine, oh my gosh, of 19 over root 903. And then they want it in radians, and they want it rounded to 2 places. So we'll go to the calculator. Oh no, they took it there. So there you go. You could just leave it there, but you could also do arc cosine of 19 over square root 903. So 0.89. But if they'll take that, then why not? If you can skip a step, if you don't need the calculator, there you go. All right, I'm sorry. I guess I'm going to have to call it here for this part because the pen is just having another conniption. I will do a part 3. Sorry about that. Hope this was helpful, and I'll see you in part 3.